This is a lecture video for section 6.4. There are going to be two videos for this section. So this is the first one. We're going to talking about equations that involving inverse trig function. So the first example we have is I want to solve the equation 3 times arctangent of x equal to pi. Remember arctangent of x, which is the inverse function of tangent. So my equation 3 times arctangent of x equals to pi. Then I can solve arctangent of x equals to pi over 3. So you can see that my right hand side of the equation is pi over 3, which is an angle format. So x is actually a number. So I can rewrite the inverse function as tangent of pi over 3 equals to x. So tangent of pi over 3 equal to x, then x is going to equals to square root of 3. And that's the answer for the first example. Okay, so the second example we have is I want to solve the equation secant inverse of x equals to cosecant inverse of 2. So here we have two parts. The first part is secant inverse of x, which I cannot really do anything with it. However, the second part, cosecant inverse of 2, this one is an inverse function, should return me an angle theta. Then because of the inverse function definition, I can rewrite it as cosecant of theta equals to 2. I'm not really too like the cosecant of theta, so I can rewrite cosecant of theta as sine of theta equals to 1/2. Because cosecant of theta and sine of theta are reciprocal of each other. On the other hand, looking at the left hand side, secant inverse of x equals to cosecant inverse of 2. So as I mentioned before, cosecant inverse of 2 is going to return me an angle theta. So I can rewrite it as a secant inverse of x equals to angle theta. Then secant of theta equals to x. Again, I'm not really to like the secant symbol, so I'm going to rewrite it as a cosine of theta equal to 1 over x. Cosine and secant are reciprocal of each other. So from those two equations, I can draw the following. I can have a right triangle with angle theta. From the first one, I know sine of theta equal to 1 over 2. So 1 over 2 for sine of theta. Looking at the right triangle, I have one leg is 1, and then the hypotenuse is 2. Then my third leg is going to equals to square root of 2 squared minus 1, which is equals to square root of 3. Combined with what I talked about before, the third leg is corresponding to 1 for cosine of theta, and then the hypotenuse is corresponding to x. So what I can draw from this picture is that cosine of theta is equals to square root of 3 over 2, which equals to 1 over x. Okay, so I'm not going to working with cosine of theta. So square root of 3 over 2 equal to 1 over x. And solving for x, I got square root 3 times x equals to 2. X equals to 2 over square root of 3. Rationalize the denominator, x equal to 2 square root of 3 over 3. And that is the answer. Okay, so this is the general way how we're going to solving for this type of problem. But because for this particular example, we have a really nice value, sine theta equal to 1/2. So instead of drawing a right triangle, I can continue working from the idea sign theta equal to 1/2. Then I know theta is going to equals to pi over 6. Considering the domain, theta is going to be in quadrant 1. I mean, considering of the domain for the inverse function, theta is going to be in quadrant 1. And because of theta equal to pi over 6 in quadrant 1, then cosine of theta, which is going to be cosine of pi over 6 in quadrant 1 equals to square root 3 over 2. Then we can still come to the same proportion that square root 3 over 2 equals to 1 over x. And then solving square root 3, x equals to 2, x equals to 2 over square root of 3. Rationalize the denominator, we still got the same answer. So this method, I can use it without drawing the right triangle because I have a really nice special triangle. Special angle, I have sine theta equal to 1/2. If I do not have it, I have to draw the right triangle to figure out each side using the Pythagorean theorem to figure out the length of each side.